Hello students, how are you all? I hope that you all are good. So the series of units and measurements is going on and we have successfully finished the 4 lectures. In a previous lecture, we have discussed about applications of dimensional analysis. Okay, in that lecture, we have discussed about how to convert the one system of units to another system of units and how to check the correctness of a given equation by using dimensional analysis. And the third application and a very important application that we are discussed about the relationship among physical quantities. Okay, that is an important concept and we have some previous year questions are there. So all these concepts that we are discussed in that previous session. Okay, I hope that you are enjoying the lectures. Okay, so the series is going on. Today we are going to discuss about session number 5, units and measurements, class number 5 or session 5. In this lecture that we are going to discuss about significant figures. Okay, so what is the definition of significant figures? What are the rules to find the significant figures? Okay, rounding of numbers in case of arithmetic operations like addition, subtraction, multiplication, division. So and all these things that we are going to discuss in this session. Okay, so my name is Rakesh Kanaganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Shall we start the session? Right. So what is the session today? Units and measurements. Class number 05. Right. So what is the topic today? Significant figures. Right. Have a look. What is the definition of significant figures? The digits of a number. The digits of a number that are known reliably plus one uncertain digit is known as is called as significant figures. Okay, so what is the definition of significant figures? The digits of a number that are known reliably plus one uncertain digit is called what? Significant figures. What is the meaning of known reliably? What is the meaning digit? What is the meaning of uncertain digit? So have a look. So I'm taking the example that is a 13.67. 13.67. So what is the meaning of significant figures? The digits of a number. The digits of a number is nothing but what? Significant figures. How many digits are there in this number? In this number, how many digits are there? 1, 2, 3, 4. That means it has 4 significant figures. How many significant figures are there? 4 significant figures. So the last digit or significant figure is known as first doubtful figure. First doubtful figure or uncertain digit. First doubtful figure or an uncertain digit. So in a given number, we have 4 significant figures. And the last digit or the last significant figure is known as what? First doubtful figure or an uncertain digit. So what is the last digit in a given number? That is 7 is an uncertain digit. That means it may or may not be true in a given number. It may exist or may not be exist. But 13.6 is what? is non-reliable value. That means it exists. It's a reliable value. It's a true value. Okay. So, but what is the 7 here? The 7 is what? It is an uncertain digit. Maybe exist or not exist. Are you getting? Simply, significant figures are nothing but what? Digits of a number. Okay now. So, what they consisting? That contains known reliability plus one uncertain digit. What is the uncertain digit? Last number. Okay, the last number is called what? Uncertain digit. So remaining term is what? Non reliable term. Is it clear? Now let us see the rules to find the significant figures. How to find the significant figure? What are the rules? Let us see. Pause the video and write the notes. 3, 2, 1, go. Right, have a look. Rules to find significant figures. Right? So the first rule. So the first rule is all non-zero digits are significant figures. All non-zero digits are what? Significant figure. Non-zero digits means except 0, 1, 2, 3 and all these things. Okay, so example. I'm taking a 2.314, second one 64521. So what is the first rule? The first rule is what? All non-zero digits are significant figures. That means have a look in a given number. How many non-zero digits are there? 1, 2, 3, 4. So how many significant figures? This number has 4 significant figures. Are you getting? So in this number, all are non-zero digits. 1, 2, 3, 4, 5. So now how many significant figures are there? This number has 5 significant figures. Are you getting? Right. So the second rule, starting zeros or leading zeros. Starting zeros or leading zeros are not a significant figures. Starting zeros are leading zeros. What is the meaning of starting zero? Have a look. Let us see an examples. So I'm taking a first example. If the number is like this 0.00264. So here 0, 0, 0. These three are called what? Starting zeros or leading zeros. These starting zeros or leading zeros never be a significant figures. So remaining digits are what? These are non-zero digits. So these are significant figures. So this number consisting of three significant figures. Are you getting? Okay. Second one 0.03456. Okay, so starting zeros 0.0, these two are what? Starting zeros. Starting zeros never be a significant figures. So what are these are the non-zero digits. So non-zero digits are what? Significant figures. How many non-zero digits are there? 1, 2, 3, 4. So how many significant figures? 4 significant figures. Are you getting? Right. So the third point, trapped zeros. What is that? Trapped zeros. That means the zero between two non-zero digits is a significant figure. So what is the meaning of trapped zeros? The zero between two non-zero digits is what? Is a significant figure. Okay, right. Example 2.0246 and second one 2. Not 2, let us take 4, whatever it is, just for an example 0060. Okay, so first rule is what? All non-zero digits are significant figures. This number has 1, 2, 3, 4 non-zero digits And second rule, leading zeros or initial zeros, no initial zeros, and they are not a significant figures. Third rule, trapped zero, the zero between two non-zero digits. Have a look. This zero is in between two non-zero digits. It is in between 2 and 2. So now it is what? It is also a significant figure. Therefore, this number has 4 non-zero digits and 1 trapped zero. So total how many significant figures are there? 5 significant figures are there. 1, 2, 3, 4, 5. If you come to here, see, so 4.006. These two zeros are in between two non-zero digits. That means these two zeros are what? Trapped zeros. Trapped zeros are nothing but what? Significant figures. Now this number consisting of 4 significant figures. Are you getting any doubt? Right. Let us see the fourth rule. Okay. Ending zeros. Ending zeros or trailing zeros. Ending zeros or trailing zeros are significant figures if they are appear after decimal without regard to the location of decimal point, without regard to the decimal point, location of decimal point. What is the meaning of ending zeros? The ending zeros are nothing but trailing zeros, are significant figures. Ending zeros is also a significant figures. When they are significant figures, if they appear after decimal, without regarded to the location of decimal point. Let us see the example. Have a look. So same example I am taking, 4.0060. 4.0060. Have a look. For what is the first rule we have? All non-zero digits are significant figures. This number has two non-zero digits, 4 and 6, plus trapped zeros. Trapped zeros means the zeros between two non-zero digits. See, in between 4 and 6 we have two non-zero digits. They are also significant figures. What is the next rule? Ending zero. Ending zeros is also nothing but what? Significant figures, but they must appear after decimal point. See, after decimal point we have an ending zero. Now this is also called as significant figure. So totally how many significant figures are there? 1, 2, 3, 4, 5. This zero is appear after decimal and it is an ending zero. So that's why it is also a significant figure. So how many significant figures are there? 5 significant figures. Are you getting? Right. So see the second one. 3.32060. 3.32060. How many significant figures are there? Try once. How many significant figures are there? See, 1, 2, 3, 4. 4 non-zero digits. They are significant. Any trapped zero? Yes, here one trapped zero is there. This zero is in between 2 and 6. One trapped zero. It is also significant figure. One ending zero is there. So this ending zero is after decimal. After decimal ending zero is also significant figure. So that's why it is also significant figure. So 4 plus 1, 5, 5 plus 1, 6. 1, 2, 3, 4, 5, 6. So we have 6 significant figures. Are you getting? Right. Let us see the fifth rule. Okay. If the ending zeros of normal number means without decimal. Okay. So normal number without decimal are not a significant figures. if the ending zeros of normal number, that means without decimal, are not a significant figures. Have a look. Example 54600. 54600. See, three non-zero digits are there. That means it has three significant figures. It is clear. 00. The ending zeros of normal number. This is a normal number. Okay, without decimal points. So these two are not a significant figures. So this number has only three significant figures. But if the number taken from a measurement, then the ending zeros are also becomes significant figures. But here these two are not a significant figures. But if the number is taken from any measurement, then the ending zeros becomes significant figures. Any measurement means I am just find the weight of a rock. So the weight of a rock I got 54600 kgs. 54600 kgs. Example. So now this number is taken from the measurement. Then these two ending zeros is also significant figures. Therefore, now this number has 1, 2, 3, 4, 5. It has 5 significant figures. Are you getting? It's a normal number. This is not taken from measurement. So the ending zeros are not a significant figures. This number is taken from measurement. Then the ending zeros are what? Significant figures. Is it clear? Write down. Pause the video and write the notes. 3, 2, 1, go. Okay? Right. So let us see the sixth rule. Order of magnitude is never a significant figure. Order of magnitude is never a significant figure. So have a look. What is the order of magnitude? Order of magnitude is nothing but what? Power of 10. Order of magnitude is nothing but what? Power of 10. Example 2.3060 into 10 to the power of minus 4. So 3.4600 into 10 to the power of 3. So order of magnitude is nothing but what? Power of 10. So have a look. This number has how many significant figures? 1, 2, 3 non-zero digits. 1 trapped 0. This is an ending 0 after decimal. This is also a significant figure. Therefore 1, 2, 3, 4, 5. It has 5 significant figures. And order of magnitude. How much? Order of magnitude is nothing but what? Power of 10. So power of 10 is equals to how much? Minus 4 is the order of magnitude. If you come to this, see 3.4600, 3 non-zero digits, 2 ending zeros after decimal, also significant figures. How many total significant figures are there? 1, 2, 3, 4, 5. It is also has 5 significant figures. Order of magnitude is equals to how much? Order of magnitude is equals to 3. See, power 3 is there. So order of magnitude is 3. Are you getting? Right. So seventh rule. The pure numbers and constants has a infinite number of significant figures. Pure numbers and constants has what? Infinite number of significant figures. Is it clear? Right. Example, if I take a perimeter of a square, okay, so perimeter is equals to how much? Is equals to 4a. It is a constant number. Then it has infinite number of significant figures. Are you getting? Write down. Let us see some examples. Okay. Right. Examples. First one. 165 to the power of minus 3. So find the significant figures. Find the significant figures. Okay. So first one. What is the first one? All non-zero digits are significant figures. Three significant figures are there because they are non-zero digits. Are you getting? Right. Comes to second one. 1, 2, 3, 4. 4 non-zero digits are there. Triple zeros. This 0 is in between 3 and 6. This is also significant. This 0 is in between 6 and 4. This is also non-zero digit. Significant figure. Therefore, how many significant figures are there? 1, 2, 3, 4, 5, 6. 6 significant figures. Comes to this. Are you able to see the board? Okay. It is a normal number. It is a normal number. It is not taken from any measurement. Then it has only two significant figures, and ending zeros are not a significant figures in normal number. Normal number means without decimal. Now it has only two significant figures. Are you getting? Right. Now this number is taken from what? Measurement. See, here they are given kg. If they appear kg, meter per second square, meters, newton per meter, like that, in front of any number, like any unit is there, so all ending zeros are become significant figures. So here 1, 2, 3, 4, 5. How many significant figures are there? 5 significant figures are there. Are you getting? Right. Here 2.000 are appear after decimal and are ending zeros. Ending zeros, if they appear after decimal, are also significant figures. So how many significant figures are there? 4 significant figures are there. So one non-zero digit, 1, 3 ending zeros. One non-zero digit, 3 ending zeros, because they appear after decimal, then they are also significant figures. If you come to this, 1, 2, 3, 4, 5, 6. 6 non-zero digits and one is trapped zero. So how many significant figures are there? 1, 2, 3, 4, 5, 6, 7. 7 significant figures are there. Right. Here 2.3 is there. This is 2. 2.3 into 10 to the power of 4. How many significant figures are there? 2 significant figures. Order of magnitude is equals to how much? Order of magnitude is equals to 4. Okay, OM means order of magnitude. Okay, if you come to this, oh, this is a large number, right? So 1, 2, 2 non-zero digits. These two zeros are trapped in between 6 and 6, 6 and 3. So trapped zeros also significant figures. These two zeros are appear after decimal. They are ending numbers. Then they are also significant figures. 1, 2, 3, 4, 5, 6. Overall, 6 significant figures are there. And the order of magnitude is equals to how much? Minus 3. Order of magnitude is nothing but power 10 power. Whatever the 10 has power, that is what order of magnitude. Is it clear? Pause the video and write the notes. 3, 2, 1, go. Okay, right. So the next concept is rules for rounding of numbers. What is that? Rules for rounding of numbers. Okay, right. First rule, the preceding digit is raised by 1. The preceding digit is raised by 1 if the next immediate digit to be dropped is greater than 5. Next immediate number is dropped is greater than 5. Are you getting? So what is the first rule for rounding of numbers? The preceding digit is raised by 1 if the next immediate digit to be dropped greater than, we dropped is greater than 5, whatever it is. Have a look. Let us see the example, then you can understand easily. Okay, Right. So the given number is 7.4265. The given number is what? 7.4265. Right. Round up to three significant figures. Round up to three significant figures. Have a look how to round up that number. Okay. So 7.4265. This is a given number. So we have to round up to three significant figures. See, 1, 2, 3. Three significant figures. Stop there. Before rounding up the number, we have to check the next immediate number. We have to check what? The next immediate number. So after 2, the next immediate number is what? 6. If the next immediate number is greater than 5, if the next immediate number is greater than 5, then the preceding digit is raised by 1. The preceding digit for this is what? 2. Then the 2 is raised by what? 1. That means, so we have to round up this number up to three significant figures. The next immediate number is 6, which is greater than 5. Then the preceding digit, that is 2, becomes 3. That means it is raised by 1. So therefore, now our answer is what? 7.43. What is our answer? 7.43. Are you getting? Let us see one more example. 3.4539 round up to four significant figures. Round up to four significant figures. So this is the question. So what we have to do? So given number is what? 3.4539. We have to round up to four significant figures. So 1, 2, 3, 4. Up to 3 we have to round up. Before rounding up, what we have to check? We have to check the next immediate number. What is the next immediate number is there? 9. If 9 is what? It is greater than 5. If 9 is greater than 5, if the next immediate number is greater than 5, then the preceding digit, that is 3, is raised by 1. That means it becomes 4. Therefore, our answer is what? 3.454. This is our answer. 3 becomes 4 because the next immediate number is greater than 5. Are you getting? Right. So rule number 2. Right. The preceding digit is left or unchanged if the next immediate digit to be dropped less than 5. So what is the second rule? The preceding digit is left or unchanged if the next immediate digit to be dropped less than 5. That means if the next immediate number is less than 5, then the preceding digit does not changes. Have a look. Example. 2.3456 round up to two significant figures. Round up to two significant figures. Okay. So what we have to do? Observe carefully. Okay. Try to do the solution, not observe carefully. 2.3456 till two significant figures we have to round off. So 1, 2. These are the two significant figures. Now what we have to check? Next immediate number. Before rounding up, we have to check the next immediate number. What is the next immediate number is there? 4. 4 is less than 5. When the next immediate number is less than 5, then what happened? The preceding digit is left or unchanged. 3 is equals to what? 3. It does not changes. Therefore, our answer is what? 2.3 only. Are you getting? Let us see one more example. 6.42345. Round up to 1, 2, 3, 4. Four significant figures. Round up to four significant figures. What is our first step? Take the given question 6.42345. We have to round up to four significant figures. See 1, 2, 3, 4. Up to 3 we have to round up. Before round up, what we have to check? We have to check the next immediate number. So what is the next immediate number? Here 4 is there. 4 is less than 5. 4 is less than 5. Then the preceding digit unchanged. Preceding digit is unchanged. That is 3 only. Are you getting? Are you see the board? Right. That is 3 only. Therefore, our answer is what? 6.423. 6.423. Right? Okay. So these are the rules for rounding of numbers. If the next immediate number, see here in a first rule, the next immediate number is greater than 5. In this rule, the next immediate number is less than 5. Here what happened? The preceding digit is raised by 1. Here what happened? The preceding digit is left or unchanged. If the next immediate number is equals to 5, here greater than, less than. If it is equals to 5, then what happened? Have a look. Okay, so what is the rule number 3? If the next immediate number is equals to 5, if the next immediate number is equals to 5, if it is greater than 1, if it is greater than 5, then the preceding digit is raised by 1. If it is less than 5, next immediate number is less than 5, then the preceding digit is left or unchanged. If the next immediate number is equals to 5, then what happens? We will get two cases. If the preceding digit is even, if the preceding digit is even, if the preceding digit is odd, preceding, we have to check the preceding number, either it is even number or odd number. If it is even number, then it is left or unchanged. It is left or unchanged. If the preceding digit is odd, then it is increased by, it is increased by 1. Are you clear? If the next immediate number is equals to 5, we have to check the preceding number. If the preceding number is even, it is left or unchanged. If the preceding digit is odd, then it is raised by 1. Let us see the example. 9.4256. 9.4256. Round up to 3 significant figures. Round up to 3 significant figures. Solution. What we have to do? Just take the given number 9.4256. We have to round up to 3 significant figures 1, 2, 3, up to 2. And what we have to do? We have to check the next immediate number. The next immediate number is 5. 5 is equals to 5. Then what we have to check? We have to check the preceding number. So the preceding number is what? 2. 2 is what? Even. If it is even, it is unchanged. Are you getting? So therefore the answer is 9.42. Answer is what? 9.42. Are you getting? Okay. If you come to here, example. So if the given is equation is if the given number is like this, 8.43356, round up to 1, 2, 3, 4. 4 significant figures. Round up to 4 significant figures. Have a look carefully. What we have to do? We have to take the given number first. What is that? 8.43356. So we have to round up this number up to four significant figures. Have a look. 1, 2, 3, 4. Round off to four significant figures. Next, what we have to do? Before rounding off, we have to check the next immediate number. So the next immediate number is what? 5 is equals to 5. The next immediate number is what? 5. Then what we have to do? We have to check the preceding number. So the preceding number is what? 3. 3 is what? Odd. If the preceding digit is odd, then it is raised by 1. That means 3 becomes 4. 3 becomes what? 4. Therefore, our answer is what? 8.434. 8.434, because the preceding digit is odd. If it is odd, then it is raised by 1. 3 becomes 4. Are you getting? Right. Pause the video and write the notes. 3, 2, 1, go. Alright. So the next concept is rounding off numbers in case of arithmetic operations. Sir, arithmetic operations. What is the meaning of operation? Take the scissors and cutting, sir. Not that operation. So operation means it's an arithmetic operation: multiplication, division, addition, subtraction. Is it clear? Right. So in case of first one, in case of addition or subtraction, addition or subtraction, how to round up the resultant in case of addition and subtraction. Have a look. The resultant of addition or subtraction is round up to the same number of decimal places, present in the value with the least decimal places. So how to round off in case of addition and subtraction? So the resultant of addition or subtraction is rounded up to the same number of decimal places present in the value with the least decimal places. I don't know whether you understand this definition or not. Example, I'm just adding a 1.432 plus 1.03 1.2. Okay, so I'm adding these numbers. So we get a 2, 3 plus 3 6, 4 plus 2 again 6, 1 1 1 3. So we got what? 3.662. Now we have to round off this resultant one. How we can round off? We have to check. So what we have to check? The same number of decimal places present in the values. In these values, we have to check the decimal places. Which decimal places we have to check? The value which is having the least decimal places. We have to check which value is having the least decimal places. Have a look. In these three, this 1.2 has least decimal place. What is the decimal place of this 1.2? That is 1 decimal place it has. Now we have to round up this 3.662 up to 1 decimal place. See, 3.6. 6 is the first decimal place. So before going to round off, what we have to check? We have to check the next immediate number. So the next immediate number is 6. If this 6 is what? Is greater than 5. When the next immediate number is greater than 5, then the preceding digit, that is what? Preceding digit is what? 6. Then it is increased by 1. Then 6 becomes 7. So the total answer is what? 3.7. Are you getting? So in case of addition or subtraction, how to round up the numbers? So in whatever the values we are added, in that values we have to check which number has a least decimal places. So 1.2 has least decimal place, that is 1. Now we have to round up the resultant up to least decimal place, that is 1. So this is result, we got 3.662. So for first decimal place we have to round up, that is 6. Before round up, what we have to check? We have to check the next immediate number. So the next immediate number is what? 6. 6 is greater than 5. When the next immediate number is greater than 5, then the preceding digit is increased by 1. So 6 becomes 7. So 3.6 becomes 3.7. Are you clear? So the same thing you have to do for what? Subtraction. Okay, right. So I'm taking a 2.303. I'm just subtracting 1.2. 1.2 from what? Or 1.3. I'm taking 1.3. I'm subtracting 1.3 from 2.303. So what we will get? So this is 3. This is 0. 3 minus 3, 0. And 2 minus 1, 1. 1, 2, 3. 1, 2, 3. So 1.003 we got. So now what we have to do? We have to round up the number. So how we have to round up the number in case of addition or subtraction? We have to check the least decimal places present in a given values. So in a given values, least decimal places is what? 1.3. It has 1 decimal place, right? So now we take the result 1.003. So we have to round up to 1 decimal place, that is 1.0. So the next immediate number 0, which is less than 5. We have to check previous number, that is what? 0. That means it left or unchanged. So the answer is what? 1.0. Answer is what? 1.0. So just in case of addition or subtraction, just check the which value having least decimal place. Right. Let us check for multiplication and division. So multiplication and division. Okay. So the resultant of multiplication or division is round up to same significant figures, as present in the value with a least significant figure. Is present in the value with least significant figure. Nothing is there. So whatever the values you are multiplying, just take those values. In that values, find the number which is having least significant figure. Then make the rounding of the resultant to that much of significant figures, either 2 or 3 or 4. Have a look. Example. 3.62 into 1.2. I'm just multiplying 3.62 into 1.2. So how much we get? 2 2s are 4, 2 6 are 12, 2 3s are 6 plus 1 7 plus 2 1s are 2, 2 6 are sorry 1 2s are 2, 1 6 are 6, 1 3s are 3. So 4 4 13 4 1 2 3 1 2 3. So we got what? 4.334. We got what? 4.344. We got this number. Now what we have to check? We have to check the values which is having least significant figures. Have a look. In these two numbers, 1.2 has a least significant figures, right? How many significant figures are there? 2. It has 2 significant figures are there. So just round up the resultant up to 2 significant figures. So take the resultant 4.344. So up to 2 significant figures, 1 2. Check the next immediate number, that is 4, where 4 is less than 5. When the 4 is less than 5, then the preceding digit is left. Therefore, the answer is what? 4.3. So same thing is also for division. Just after doing the division, check which value having least significant figures. And is it clear? Any doubt? Right. So this is the end of the today's session. We will meet on another lecture. Okay, that is units and measurements lecture number 06. Okay, I hope that you understand all these concepts. Okay, we will meet in a next lecture. Until then, stay tuned. This is Rakesh Kanaganti signing off. Jai Hind.